Hello, welcome to Circuit 2. This is an example of impedance simplification levels 1 and 2. We begin on the main menu and we choose the first one. Here we're going to determine the hertz. That's going to be part of our equation. Of course, that's J times 2 pi times our frequency. In this case, note that it's 50 kilohertz times 80 microhenry, which we write micro as 10 to the negative 6th power. You can use the keyboard icon to get the to the power of icon. For a capacitor, of course, the equation is 1 over J times 2 pi times our hertz times 4 microfarads in this case, which we once again write as 10 to the negative 6th. You can, as I did here, just use the up caret on your keyboard. That's usually attached to the number 6. We see that the numbers are correct. Now it's time to simplify. These are all in series, so we'll simply add them. This part's quick and easy. You can move the box out of the way for better visibility. Because they are all already in their phasor format, we can simply add them. If you were doing this in DC format, you would have a couple extra steps, but that will be in a separate video. In here, we'll just add our inductor at 25.13 J, plus our 1 ohm resistor, plus our capacitor with a capacitance of negative 0.795. We'll short circuit the other 2 components and keep one of them as the equivalent impedance component. And here this problem is done. We will now move on to a slightly more difficult problem, which is only more difficult because you need to do the same steps multiple times, but we know what to do, so we'll get to it. We've determined that it's a 1 kilohertz system, which matters because that K, it's easy to forget. It's not 1 hertz, it's 1000 hertz. So, same equation as usual, our JW. So, J times 2 pi times our hertz. Again, notice that it's 1000 hertz, or 1K. In the future, you'll be able to abbreviate 1K on the website, but as of now, play it safe at 1000 times 600. Remember, that's a micro Henry, so 10 to the negative 6th. Now, we already know how to do inductors. I'm not going to waste your time doing it 3 times over. It'll be the same thing, rinse and repeat. So we'll move on to the capacitor, where we have 1 over the same equation to start, J times W, W again being 2 pi times the frequency, times the value of our capacitor at 30 microfarads, which again, micro is just 10 to the negative 6th. We can see that is correct, so I'm going to go ahead and show you detailed calculations made by the software, again, so as not to waste your time, so we can get to the fun stuff. Now here we're going to combine series and parallel. I advise doing a series whenever it's available, if it's available at the beginning, because it's easy and simplifies the circuit without fractions. So if you can make it simpler, make it. In this case, we have 8 plus 3.77J. And system will load, and we'll do it again. 4 and 0.628J will get added because they are in series. Now we're gonna do, what are we doing next? Another series? Yeah, series on the bottom, or we could do parallel on top. Let's do series on the bottom. Again, wanna knock out as many of the easy ones as I can before we start having to do fractions. Okay, with that out of the way, we can now simplify this in parallel, which will just be 9 times and 9 plus the 4 minus 0.62J. I made a typo, so we're going to go ahead and skip that, but you can see the right equation is up there, and we'll move on from it and do a couple more parallels to show you the typing process. And in this case, we're going to do our I find it easier or quicker to do 4 over 4 and then begin my equations. Just that way I don't have to mess around with what the computer is trying to make the fraction about. But as long as you end up with this format, you can get there any number of ways. As they say, there's more than one way to fry chicken. And here we check that it's correct and send it to continue to simplify the system. And now this next part is more or less self-explanatory. We rinse and repeat the same process. Some are going to be in parallel, some are going to be in series, and our goal, of course, is always to see what's available, and something almost always is available. So in this case, negative 5.305J and 2.786 plus 0.381J. And just like that, we've simplified a system that had more than 10 items in it into one that now has just 6. Okay, we see another. Now that we've done a couple parallels, we can see that this is one that's not in series because it's shared on 2 different circuits. This one too. They are part of the same mesh, but a number 2 ohm resistor is also a part of a secondary mesh. Now we could connect these 2 in parallel, and we will, just to get some more parallel practice. But we could also do the top mesh with 2.7 and 2.5 and add them in series, which we will eventually. The key takeaway is order of operations here does not matter. You can do any simplification in any order you so desire. Get tired of fractions, do some series. Got tired of series, do some fractions. Up to you. It is important to note when you're doing AC impedance simplification that it works a little different from DC in that our rules for how we add capacitors or how we add inductors are different. As you may recall, an inductor works almost opposite. A capacitor works almost opposite to how an inductor works as far as the rule for series versus parallel combination goes. So just make sure that you understand that this process of changing our devices to phasor format and then just adding them like it's all resistors is strictly for AC. Now here you notice we're reaching the end of our problem. We have a couple items in series. Once these get out of the way and become one, we'll be able to combine them in parallel with the 1 ohm resistor. And once we do that, we'll have a system that's that much simpler than we started with. Making sure to check that it's correct. It'd be deeply embarrassing if I made another typo. So here we go. Okay, now we'll do another parallel combination, which will allow us to have our 2.78 and our current 1 ohm resistor in a series format, all in the same left side loop. And then at the very end, we'll have the 2.7 and the other 2.7 be in parallel. Thus, we are a mere 2 steps away from finishing this circuit. If you got the gist, you're welcome to stop the video now, but I'll proceed here to completion. Note that the entire system isn't in series, but only the 2 on the left, as the 2.7 on the right side is a part of a different loop entirely. They're all in the outer loop, but remember, we need to share the same loop and only the same loop. Or share 2 different loops, but they must be all a part of the same system. Now we've added them them in series, and we're left with a 3.6 and 2.7 in parallel, as I promised, which will be a pretty long one. So for something like this, I do advise you make use of the copy and paste feature up and down, just to make your life a little faster. It shouldn't take 2 whole minutes to type this out. I was not very efficient in my typing here, but you can be. So there's some light use of the copy and paste feature. Truly wise would have been to write the entire numerator and then copy and paste it onto the bottom numerator, and then just swap out the times sign for a plus sign on the bottom one. But that's the beauty of hindsight for you. Now in 1 more minute, we'll have this finished up. Parenthetical use is important. Note that I have used parentheses every time there's a complex number involved. It's a good habit to keep. It ensures the computer is on the same page as you. And here we go. The problem is completed. We got 80% because of the typo I made earlier, but always done.